Hello, everyone. Welcome to our talk today. Thank you so much for your interest. My name is Chin Zhu. I'm a research assistant professor in the Division of Humanities, Arts, and Social Sciences, and also the Ethics Across Campus program. This event is supported by the Daniels Fund program in professional ethics education. My colleague Sandy Woodsum and I, we are co-directing this program. Sandy is not able to be here. She's on medical leave. Our program, the major goal is to support the faculty in their efforts to integrate ethics into the courses. We're still accepting applications for this fellowship. If you are interested, let me know. We can talk about it after this lecture. Besides supporting ethics integration, this program also supports a lecture series we just created on the ethics of emerging technologies. Today we have Professor Christopher Preston from University of Montana. He will talk about ethics of emerging technologies, especially synthetic biology and other emerging technologies. And next semester would be doing other similar events, including topics such as the ethical significance of sending messages to outer space, and also ethics of robotics. We're actually planning on doing a panel on ethics of robotics and cybersecurity. So please stay tuned. Let me say a few words about Dr. Christopher Preston's background. Dr. Christopher Preston is a professor in the Department of Philosophy and a research fellow at the Mansfield Center's Program on Ethics and Public Affairs at the University of Montana. He works in environmental philosophy, climate ethics, the ethics of emerging technology, and feminist philosophy. His books include Saving Creation, Nature and Faith in the Life of Holmes Ralston III, and Grounding Knowledge, Environmental Philosophy, Epistemology, and Place. His newest book, which is here, is called The Synthetic Age, Outdesigning Evolution, Resurrecting Species, and Re-engineering Our World. This book has recently been published by the MIT Press in March 2018. So if you are interested in this book, and you can check this out at our bookstore. We have several copies for sale. With that, I'm going to turn it over to Dr. Preston. Please join me in welcoming Dr. Preston.
Thank you very much, Chin. It's lovely to be in Colorado. Some of you probably know Sandy Woodson, Chin's colleague. Sandy's a dear friend of mine. We were in graduate school together in Fort Collins. And so I'm looking forward to getting to see her whilst I'm here. But it's lovely to be here. Thanks for coming out. I'm going to start off by covering a couple of things that I covered yesterday. I gave a presentation to some students, and I set the scene by talking about this idea of the Anthropocene epoch, and then pushing past the Anthropocene epoch into what I call the synthetic age. So I'm going to start by just going over that again. So my apologies to Joseph and Chin and a couple other people who I recognize from yesterday, but it's always good to recap stuff, right? And then when I've done that, I'm going to use that discussion to move into what I think is something we should be thinking about with emerging technologies, which is the constant presence of wildness. So the ineliminable aspect of wildness in the things that we build. And that will take a little bit of explaining, and that's sort of the body of the talk. So I'll get there in a second. So just to sort of lay out where we're going, I'm going to start with these discussions of these technologies in the context of the Anthropocene and the synthetic age. And then I'm going to make a general claim about artifacts and wildness. That's not my claim about artifacts and wildness. I'm borrowing it from a philosopher of the environment called Stephen Vogel. But I'm going to lay that out in section 2. Then I'm going to say, well, what happens when you take that claim about wildness and you attach it to these technologies of the synthetic age? And then I'm going to sort of close it out by making some recommendations from the perspective of ethics. So that is my home territory is ethics. My home department is philosophy. My particular specialty is environmental ethics. And now, more recently, how emerging technologies affect environmental ethics. So let's start by just making this general claim about the Anthropocene, the synthetic age, and certain technologies. So I think you're all familiar with the idea of the Anthropocene, the idea of this new geological epoch where there is nothing left on the planet that doesn't reveal the trace of human action. And that's simply a reality, it's simply a fact. There is nowhere on the surface of the Earth where the traces of human activities cannot be found. And so the suggestion is we've got this new epoch. It follows the Holocene. It's called the Anthropocene. It's been formally recommended by the International Commission on Stratigraphy's working group. It hasn't formally been adopted, but we're kind of in that process. So the Anthropocene has become this big deal. It has escaped the geosciences. And this is sort of a remarkable thing. Most geosciences are not sort of at the height of popular culture. No disrespect to any geoscientists in the room. But it is interesting that this term, which comes out of a particular discipline and then a particular sub-discipline within that discipline, stratigraphy, it's become something much bigger. It's become this kind of cultural meme. Everybody is talking about the Anthropocene. And it sort of has fuzzy boundaries now. It can sort of cover all kinds of things. And people play off the word Anthropocene to create all other sorts of scenes. And it's really, the term I used yesterday, it's become a charismatic mega category, this sort of dramatic, exciting thing that everybody's talking about. Now, I think it's a misnamed charismatic mega category. Misnamed because all of those effects that have led to people saying the Anthropocene has begun are accidents. At least they're accidents on the scale at which the stratigraphers are considering them. So take climate change, for example. You burn fossil fuels to increase standards of living, generate wealth, and free people from backbreaking labor. You don't burn fossil fuels to create a warmer temperature. That sort of happens as an accidental byproduct of something. You put pesticides on fields in order to increase crop yields. You don't put pesticides on fields in order to put those pesticides into the livers of creatures around the world, including up in the Arctic ice. So what you intend to do in all of these cases that everybody is citing as evidence for the Anthropocene is something usually local, something usually directed at a type of human good. What you intend to do is not to create planetary scale changes. You don't say, what can we do to the Earth today? How can we change the Earth in a certain way? That's not what has happened in any aspect of the Anthropocene. But what if you could do that? What if you could say, let's change how the Earth works? And let's set about doing this deliberately. Let's get a hold of a bunch of technologies and use these technologies to alter fundamental earthen processes and create a new type of planet. That's what I think is happening. So I think technologies are emerging right now that allow us to take what in this Anthropocene discussion was sort of a bunch of accidental messes that we created and replace them in what I call the synthetic age with a planet where some of the fundamental formative processes are deliberately, intentionally shaped according to our own design. That would be a different type of endeavor, I think. And so I don't call it the Anthropocene, I call it the synthetic age, where we, if you look at the subtitle, we literally say, you know what we're going to do? Let's out-design evolution. Let's create something more powerful than evolution. Let's bring species back and kind of repopulate the Earth through de-extinction technologies. And let's re-engineer our world through climate engineering, for example, where you decide to intentionally change the climate. Not accidental climate change, an unfortunate consequence of something else we were trying to do, but climate engineering when you intentionally set about creating a new climate. So I think the synthetic age is different from the Anthropocene. I think it's more significant. I think we should be paying attention to this that lays ahead, rather than putting a lot of energy into thinking about all the accidental consequences of what we've done rather inefficiently, messily, and unfortunately over the last couple of centuries. So the metaphor I use for what's going on in the synthetic age is that we're getting into Earth's metabolism. We're not just affecting it at a superficial level, we're affecting it at some metabolic level where we're getting our fingers into the processes that shape the Earth. And the two examples I'm going to talk about today, when I get into the discussion of wildness, that I think embody this kind of character of activity the best, are climate engineering, and especially climate engineering with solar radiation management. Because if you are managing the amount of solar energy that is coming in or going out of the atmosphere, and you can do this sort of at various levels. You could do it actually before you enter the atmosphere with space mirrors. You could do it up in the stratosphere by depositing stratospheric aerosols. You could do it in the troposphere by brightening clouds, or you could even do it at a terrestrial surface by increasing the amount of light energy that gets bounced off the surface by creating more and more wider surfaces, increasing the albedo of the surfaces. If you do this, if you change this, you're changing something that is a fundamental flow, a fundamental part of Earth shaping processes. And I think that's sort of a big deal. And this is, my philosopher person's attempt to specify, all right, Christopher, what's the big deal about it? Well, the big deal about it is intentionality and design gets put in to those earth-shaping processes. And that has not happened before. That would be crossing a new threshold. So when I say that's not happened before, you might say, oh, come on, climate change. We've been talking about it for 20 or 30 years. Surely we've had planetary scale effects before. And hopefully it's clear already from what I've said. Yes, we've had planetary scale effects before, but they haven't been intentional. And this guy, David Keith, who is one of the most enthusiastic advocates for research on climate engineering, he makes it clear that what we've done up till now is not the same. Because what we've done up till now has not made the Earth into an artifact. It's changed the Earth, but it has not made it into an artifact. And in this essay, he talks a lot about the difference between engineering and making a mess. There's a difference between engineering something and simply making a mess. When you're engineering something, you're creating an artifact. And so we're not yet there, says David Keith. So I think solar radiation management, that form of climate engineering, is a really good example of what this synthetic age might mean. And I think another really good example of what the synthetic age might mean is synthetic biology, the idea of building genomes to create organisms that produce useful functions for us. So as some of you might know, the goal here is being pursued by people like Craig Venter at the J. Craig Venter Institute, is to design a minimal viable genome that could keep a bacterium alive. And then on top of that minimal viable genome, which they call a chassis, you then put in what they call biobricks, so that that chassis, with the addition of those biobricks, does things for you that you think might be useful. And what sorts of things are those? Well, you name it. The world is your oyster. Maybe bacteria that help with bioremediation of contaminated sites. Maybe bacteria that help produce biofuels, or bacteria that are particularly good at grabbing carbon out of the atmosphere. So synthetic algae, for example, might be something you do. I heard Craig Venter give a talk a few years back, and he stood up there at the front and he said the world's first trillionaire will be the person who develops and commercializes a useful synthetic bacterium. I don't know how much Craig Venter is motivated by the money. I think he's probably got plenty of money already. But the power of these technologies, I think, is clear through a statement like that of Venters. So that, to me, is also a radical move. If you can build genomes and build organisms that do your design, do your calling, you've really sort of crossed a threshold into a different kind of world. You've crossed the threshold into a synthetic age. And I think somebody asked me this yesterday, is there a date when the synthetic age begins? Or how long is the sort of window of transition? And I don't have a good answer to that. But I would say it's a sort of happy and interesting coincidence that at the same time as this Anthropocene discussion is taking off, so are we on the cusp of bringing these sorts of technologies towards commercial application or towards use. And so with climate engineering, for example, this summer in June, a Harvard group is going to run what they're calling the SCOPEX experiment, which is an experiment in atmospheric perturbation, they're calling it. That's the P in the SCOPEX. And they're going to see if you mess with aerosols in the stratosphere, how do the energy thermodynamic properties change? And they're going to loft a balloon in Arizona, and they're going to deposit materials in the atmosphere, and then they're going to sense the change in thermodynamic properties up there as a result of that. So we really are right on the cusp of this sort of stuff happening. And Craig Venter, the synthetic biologist, it was 2010 when he first replicated a genome in the lab and put it into an organism. 2016 when he constructed a minimal genome and put it into a bacterial organism and had that minimal genome take over the function of the organism. So that's my intro to the synthetic age. That's all a repeat from yesterday. And certainly I'm happy to discuss that when we get to the end today. But I want now to move on to a different thinker and a different claim, but one that I think is highly relevant to what I've just laid out for you, and make a certain claim about artifacts. So artifacts are the things we build. And I think of those synthetic organisms as artifacts because they have human intentionality and design in their genomes. I also think of a climate-engineered Earth as an artifact. So that's a slightly less traditional use of the idea of artifact. But I think if you are influencing processes as fundamental as the amount of energy that arrives on the planet's surface, you are creating an artifact Earth, an artifice Earth. And that's picking up on that David Keith quote that I had up there, Earth is not yet an artifact. Well, not yet, but it could be quite soon if we engineer climate in the way they're talking about. So, what is the claim about artifacts? I'm going to switch over now to this guy, Stephen Vogel. So, a philosopher based in Ohio at Denison University, who wrote this book, Thinking Like a Mall, a couple of years ago. It's a 2015 book. And if you look at the subtitle, Environmental Philosophy After the End of Nature. So he's in my field, he's an environmental philosopher. And for a long time, he's been interested in getting rid of the idea of nature. So this is an agenda that you might not all relate to. It's kind of a big deal in the environmental ethics literature. Why is it a big deal? Because environmental ethics has tended to say there's this thing called nature out there, and nature has some sort of significance to it, moral significance, or you might call it religious or spiritual significance. And nature somehow commands us in certain ways. We need to respect it and we need to honor it. And in fact, when I came over to the United States 25 years ago, I studied with Holmes Ralston up there in Fort Collins. That's the view that Ralston holds. The view is that there is intrinsic value, moral significance in this thing called nature, and we need to sort of somehow be in the thrall of nature, or at least we need to listen to it and respect it or recognize its value. So this guy, Stephen Vogel, says it's nonsense. This idea that there's something out there that tells us how to behave, it's really, he worries that it's kind of a way to make ourselves vulnerable to nature ventriloquists who come along and say, this is what nature wants, all you guys should stop doing this. He worries that it's a way for us to sort of lay ourselves down in front of the power of something that nobody really can sensibly say what that power is or what it means. So he says, let's just get rid of the idea of nature. So he has a couple of books, this one and another one that's simply titled Against Nature, where he tries to dispatch from the environmental discussion any type of notion of nature. So it's kind of a radical idea, right? Part of how he does it is he tries to undercut the distinction between nature and artifact. So this is where it ties into the story I want to tell today. He wants to say it doesn't make any sense at all to distinguish these things called artifacts from this other stuff that's called nature. And the arguments that he makes are very varied. I mean, he's got a whole book on the topic, right? They include the Anthropocene type of discussion where there's nothing that's natural anymore. But really his key sort of driving way of making this case is to say it's just incoherent to think there's a clear category that is the natural and a clear category that is the cultural, and those things are never the twain shall meet. You know, those things are apart from each other. He says that's just incoherent. One of the ways he does it is to say, you nature people think wildness is in nature and not in artifact. I'm going to show you that there's wildness in artifact. And so thinking like a mall, this is a picture of a mall in Ohio that has sort of gone to hell. It's sort of lost its economic value. It's started falling down, and eventually it was actually demolished and kind of removed from the site. And so quite a lot of what he does in the book is explain how even those things that are heavily designed have wildness in them. Malls have wildness in them. So thinking like a mall, some of you will recognize that's a play on Aldo Leopold's famous line, thinking like a mountain, where Leopold says, you know, mountains have this wildness, this mystery about them. And what Vogel's saying is that, well, malls have this wildness, malls have this mystery about them. And so we need to think about wildness in our artifacts like that. So let's dig in on wildness a little bit. We're all familiar with the idea of wildness through people like Thoreau and John Muir and Aldo Leopold. And trying to define what wildness is, I think, is a fool's game. I try and avoid it because wildness is this sort of ineffable, mysterious kind of property of things. But I pick up a line from the philosopher Mark Woods, who actually did his PhD here down up the street in Boulder, who thinks of wildness as an internal capacity for autonomous, authentic, and spontaneous expression. And so thinking about these environmental philosophers, you would say, oh yeah, that you find that in grizzly bears, you find that in wolves, you find that in avalanches, you find that in earthquakes, you know, this sort of spontaneous, autonomous type of expression. So it's easy to think of wildness in nature that way. But remember, what we're trying to show, if we're going to follow Vogel's arguments, is that there's wildness in artifacts. That's what Vogel's trying to show. And so that's what we're hopefully going to try and show. Why would we think there is wildness in artifacts? First of all, you're going to have to start by thinking of wildness a little bit differently. So I think when Vogel comes up with a definition of wildness, he sort of shrinks it down. I mean, it's recognizable from the definition that Mark Woods came up with when he was talking about nature. But this is a little more of a minimalist type of definition, where wildness is any forces in an object or organism. So, you know, by saying object as well as organism, you know that Vogel's steering this argument towards things like malls as well. And the key here, it's less sort of autonomy, which is something you would think about with grizzly bears and wolves, and it's more things like unpredictability, and also something that escapes the grasp of the human actor. And so again, you know, thinking of that mall, the people who built the mall, they had an idea that they put into practice and literally put into steel and concrete and glass. And the wildness in the mall is something that escaped their idea. So you can see his definition is going to be a little more mall-oriented, less wolf-oriented than the one that the environmentalists that I had up there before offered. So let's drill down deeper on this and really try and unpack what Vogel means when he says that artifacts have this wildness in them. Now, it's a position that he spends 2 or 3 chapters articulating. It's quite counterintuitive, I think. And the way I'm going to present it to you is through 6 lines that Vogel offers, so that you can really sort of get a sense of what he says when he says there's wildness in artifacts. I'll do my best to interpret them, but this does require you to sort of read what he's saying there and to think about what he's saying there. So one part of wildness is that whatever you build always exceeds your intentions. And you might recall when I had the slide Wildness in Artifacts, I had 3 pictures. And one of the pictures was a wheelbarrow with flowers growing in it. And the wildness in that wheelbarrow with flowers growing in it was not the wildness of the flower. It was the wildness of the fact that it was a wheelbarrow serving as a flower basket. So the person who designed and built the wheelbarrow wasn't thinking, I'm going to design and build something to hold flowers. They were thinking, I'm going to design and build something that'll help you move heavy loads around a yard or a construction site or something like that. But the thing that gets built always exceeds the intentions of its author or designer. So that's one aspect of wildness. This claim makes what I just said a little more general and makes it in a slightly more abstract way. He says what it is to make an artifact when you make it real is you take something from your mind, something you've designed, and you put it out in the world. And out in the world, it has immediately escaped, and literally escaped, your mind. Okay, so I might be thinking, wheelbarrow. I'm going to design and build the best wheelbarrow ever. But when I make it real, I realize my idea. I make it real out there in the world, and then it's sort of lost the tethers that it had when it was in my mind. Okay, this is a little bit of an abstract point, but I hope you can kind of see what he's saying, that the item now has a life of its own that escapes whatever I had as an intention for it. So artifacts always surpass intentions. What else do artifacts do? Artifacts always put processes into motion. So I had up there before a piece of metal that was rusting and corroding. So as soon as you make something real, so as soon as you take it out of your head and you put it out in the world, you are exposing it to processes that are not your processes. They are processes like gravity, heat, decay, oxidation, entropy. You're putting that thing you build out there, and it's almost like you're saying, all right, go. And what's happening is these processes are starting their work on the thing that you have built. So creating artifacts is not only creating something that automatically exceeds intention, it automatically puts processes into motion. And because those processes are in motion, at the instant that thing becomes real, it's escaped. So this is another way of saying that point that was on the previous slide. On the previous slide, it was escaping intention. On this slide, it's escaping intention and escaping the sort of clean design that you had for it in your mind, and you're putting it out there in the world where the world starts operating on it. Okay, one more slide with a couple of quotes on it. Vogel talks about this wildness in terms of a gap. And the gap is, he says, an ineliminable feature of building something. There's sort of this space between what you intended and what happens, a gap. And it's in that gap that wildness resides. And this last quote sort of illustrates how he's trying to get at this nature-artifact distinction that he wants to get rid of. He's trying to sort of zero us in on that. And he's trying to say that every artifact has a nature. So he's playing with words here. And this is, I hope you're sort of hanging with me here because it is a little bit complicated, but he's playing with words here and he's saying, you know, we want to say that nature is one thing and artifact is another thing, but really artifacts have a nature too. They're natural, and part of their nature is to be wild. Now, let me just clarify one thing that he's not saying and gesture towards one thing that he is saying. He's not saying that somehow we just don't know enough, and if we knew more, we'd be able to eliminate this wildness from the things we build. It's just a matter of being better engineers, better designers, doing more research. He's not actually saying that. He's saying that it is part of the very character of things that we build, that when we build something, it's sort of an exchange between us and world, this sort of, to use a fancy word, like a co-construction. It's like this exchange where I have an idea, I put it into motion, I put it into action, and the world keeps kind of acting back on me. And so anything that I build has this wildness inherent to it, and it is ineliminable. That's the key to it. You can't get rid of it by just doing better design. It's always going to be there. I think a good example of this is the Tacoma Narrows Bridge, and I'm sure I'm sure at this school, almost all of you see this at some point in your education. The video is just fantastic. It's got a sort of 1940s voiceover and dramatic music in the background whilst this guy tries to figure out if he can rescue his vehicle from the bridge. So that's a sort of classic example of it, but you know, there's other examples of it too. I mean, this was 2 days ago, that engine on that Southwest jet. And this is an ineliminable wildness, okay? I mean, those jets are really well built. They're really reliable. It's not that it's bad design. It's just part of the process of constructing an artifact. Okay, so that's the claim about wildness in artifacts. So where are we in the talk? We start off by saying there's certain types of big technologies out there which are contributing to a synthetic age where our artifacts become earth-shaping. Now I've claimed that our artifacts have this wildness to them. So what happens when you put these two claims together? What happens when you take that wildness and you say, all right, wildness ineliminable, even for things like synthetic organisms or things like engineered climates. What does that mean? What's the implications? Well, the first thing I want to say is I think it's helpful to think about two different types of ineliminable wildness. So one is a physical type of wildness, and this is the sort of Tacoma Narrows Bridge thing, but this one's down in Florida, you remember, a little bit earlier this year when this bridge that was under construction came down. So definitely there's that sort of wildness, but there's another sort of wildness too, which is social. And I want to make sure that we have social wildness in this discussion as well as that physical wildness. And so wildness is those things that escape predictability, something like a spontaneous happening or force that we could not have predicted. I want to talk about both of these sorts of wildness in the two technologies that we have on the table right now. So we have solar geoengineering as one of our artifacts. So a solar geoengineered Earth as one of our artifacts. And is there physical wildness in this artifact? Absolutely. So I've been involved in the discussion of the ethics of climate engineering for the last few years. And there's all kinds of stuff that even the scientists admit they may not be able to figure out with the type of precision that could make solar geoengineering completely safe. So the most commonly mentioned physical wildness, now the geoengineers don't use the term wildness, I'm just giving it to them and hoping that they will use it. But the most commonly discussed type of wildness is the unpredictability of the precipitation patterns if you put stratospheric aerosols in the sky around the world. And the initial claim that turned out to be a slightly exaggerated claim, but the initial claim is that it would move monsoons around. It would change where they happened, it would change when they happened. And of course the worry here is if you move monsoons around for people whose lifestyles are tuned into those monsoons, their agricultural patterns are tuned into regular or fairly regular precipitation patterns, you risk creating a great deal of hardship for the very people you're trying to help by cooling down the planet. So the concern about precipitation is one of the physical uncertainties. A concern about what the deployment of stratospheric aerosols will do to the ozone layer is one of the uncertainties, as well as what stratospheric aerosols will do to the electrical properties of the atmosphere. And also the worry about what creating more diffuse light would do to vegetative patterns. So actually more diffuse light is better for photosynthesis. And so there have been some papers written by solar geoengineers saying, you know what, if we solar geoengineer, we're actually going to improve food prospects for the people that matter around the globe. But when you sort of tie that into the vegetation, the precipitation changes, it's not exactly sort of clear. I mean, some models suggest that maize yields, for example, go up with solar geoengineering, but this is not conclusive evidence. And the climate can be modeled to some extent, but even those with the most enthusiasm for climate models acknowledge that it can't be modeled with the type of precision that is going to be necessary to guarantee that the people who you want to be better off are going to be better off. So I think, having looked at some of the arguments that are brought against climate engineering, you can see that there is physical unpredictability, and I'm going to call it wildness, in the attempt to create an artifact out of the earth. But there is also social wildness. So if you look at the literature on the ethics of climate engineering, there's a big worry about unilateral actors, people who would go out there and do this because it benefited their country or just even benefited their interests. So they talk about a green finger scenario, which is like a play on the Bond movies, Goldfinger. Green finger scenario is somebody who's very rich, who just decides that this is a good thing to do, and then they go out and do it by themselves. They change the climate by themselves through stratospheric aerosols. And there's an unpredictability about that. There's an unpredictability about the kinds of tensions that a geoengineered climate might cause, because everyone's climate's going to change. Some people might want their climate to change in a way that is different from the way other people might want their climate to change. So, the Canadians might like the fact that they can grow crops on more of their landscape because the place is a bit warmer. Pacific Islanders might not like any aspect of increasing warmth because of sea level rise. So there are geopolitical tensions which are not going to be entirely predictable. There's something called the termination effect, and this is the worry that once you've started climate engineering, you're basically screening out warming even while CO2 is still building up in the atmosphere. And if for some reason you have to stop that screening, why might you have to stop it? Maybe for political reasons, maybe because you find out that there's a physical effect that you hadn't anticipated. If you suddenly have to stop that screening, you have a very high concentration of carbon in the atmosphere and no screen left anymore. And so temperature shoots up really fast. The termination effect, and then finally the worry of moral hazard, which is the idea that if you have a technology that seems to solve or at least partially solve your problem, you don't focus on the things that you've all agreed that were important, such as reducing the amount of carbon in the atmosphere and transitioning your economy over to renewable economy. So climate engineering socially might provide this hazard that prevents you from doing what everybody previously agreed was a good idea. So geoengineered Earths, artifact Earths, have a potential for physical wildness and social wildness in them. So with this quick look, I think Vogel is right that we can't forget the idea of wildness in things like artificial Earths. Let's move this discussion back over to synthetic biology and run the same sort of analysis. So physically, there are things about synthetic organisms that are uncertain and perhaps a little bit worrying, particularly in terms of health and environmental sorts of effects. And this applies especially to organisms that are deployed outside of the laboratory. And there's sort of a big discussion at the moment in synthetic biology over whether what we're talking about building organisms that would stay in the lab and just do something for us in the lab, or is what we're talking about synthetic organisms that we would take out of the lab that would do something for us out there in the world. I think a lot of people are saying, well, look, if you're going to create real public goods, you're talking about things out there in the world. So let's assume we are talking about synthetic organisms that will eventually be deployed in the world somewhere. There's a whole suite of worries about certain things that could happen if those organisms were out there in the world. In the idea that they would outcompete existing bacteria, they would interfere with the DNA of organisms that are out there, that they would change, they would become things that were not what they were designed to be. So when the artifact is made real, it escapes the intentions of the designer. So those are types of physical worries that I think are associated with synthetic biology. And then also the social worries. So just as with climate engineering, there are these social unpredictabilities. So are there social unpredictabilities with synthetic organisms. And the big one is biosecurity. This worry that these organisms could be used for nefarious purposes by terrorists, foreign governments, you name it, whoever your sort of preferred security threat is. Certainly there's a worry, and this is a worry that some of the people in the synthetic biology community are taking very seriously. Craig Venter especially, every so often he has a conference on biosecurity issues with the synthetic organisms he's designing. I want to put one more unpredictable social consequence of a synthetic organism: the potential for unanticipated social disruption. And just by analogy, perhaps, I guess, think of how the internet was supposed to democratize things for us. You know, it's going to make information widely available. We'd become better analysts of situations because we'd have the information available, and we would have societies that were generally better informed and better able to think through problems. Has that happened? Not at all. You know, what's happened is we've become increasingly polarized. We found these echo chambers where we're really happy to reside. So we just listen to people that reinforce our views. We ignore people whose views go against ours. And actually, we've become less capable of analyzing problems, less able to use all the information out there to think through what's going on. So potentially, if synthetic organisms are this powerful, if they are global and powerful in ways that they transform our problems in ways that are dramatic, it might create analogous effects to the internet, in the sense that it changes social arrangements, changes arrangements between humans and nature in such a way that we hadn't anticipated it, and possibly things don't end up as sort of sweet and as smooth as we imagined them to be. So I think this worry of wildness, or the concern about wildness in our artifacts, I think it shows up in artificial climates, both physically and socially, and it shows up in artificial organisms, both physically and socially. So I take that worry that Vogel brought to the table, and I think Vogel's fairly prescient about that. I think he's sort of pointed his finger at something that is important. So I'm an ethicist. Where does that leave me? What does that make me feel. The idea here is not to panic. Like, the idea is not to say there's this wildness that is out to get us. But the idea is to say, all right, if there is this wildness in the things that we build, if emerging technologies will forever have this ineliminable element that we're always going to have to be on the lookout for, how should we proceed? How should we react to that? So in the book, where Vogel talks about wildness, so we're reading the book now, actually, with some of my graduate students in one of my classes, called Issues in the Anthropocene. That's the name of the class. We're all saying, come on, Steve Vogel, come on, Steve, give us your recommendations. How do we act in the face of this wildness? And his answers are actually somewhat helpful, but not exactly prescriptive. They don't tell us exactly what to do. He basically says, well, given that our artifacts are always going to have this unpredictability to them, then maybe we should adopt attitudes that are cautious attitudes. So we should be humble. We should recognize that we as designers are fallible. And we should recognize that even the best designers are going to create things that immediately escape their plans and their intentions. And so we should be tentative. We should not be supremely or overly confident about the kinds of things that we build. And we should just be fully conscious of what we're doing all the time. We should have a lot of self-knowledge, or I put self in parentheses because really he means knowledge. We should just really think broadly about the changes that we're making. And so this is a claim that I think good philosophers of technology are constantly making, that the technology is not just the item. It's the item as it gets deployed in a society and as it changes that society. Think of iPhones, think of anything that has a dramatic social type of effect. So this is what Vogel gives us. My students are saying, Vogel, you need to give us more than that. That's not enough. And I think it's not enough. I think we should be saying more. So I want to add a little bit more. I want to start by adding something that Kevin Esvelt, who is a synthetic biologist, has been saying a lot recently. He's part of a lab in MIT called the Sculpting Evolution Lab. So the subtitle of the book, Out-Designing Evolution. This is what these folks at MIT are doing. They are sculpting evolution. They're shifting it in certain directions. And Kevin Esvelt has been researching the particular element of synthetic biology he's been researching is the topic of gene drives, which are little genetic packages that you would insert into organisms. You would insert into their germline, and then you would let those organisms go out in the world and breed with that package of useful genetic material in its germline and spread it out through a population. So this is a sort of designed way of affecting wild populations through gene drives. So Esvelt has been very keen on this for the last few years. But he recognizes that a technology this powerful, and it is this powerful because you could use this technology to spread terminator traits out through wild populations, to kill off species that you didn't like, or to change species that weren't quite doing what you wanted them to be doing. He says with a technology this powerful, we need to make sure that we operate with complete transparency. How much transparency? All of it. All of our research should be completely transparent. So just to sort of tie this back into the larger story I'm telling, in the synthetic age, we have technologies that are shaping the planet in fundamental ways that the planet has not been shaped before. Esvelt, who is working on such a technology, says the only way we should develop this type of technology is with complete transparency. So a much more public type of approach to how you do scientific research than is common. So getting rid of things like patents, he sort of gestures in this direction, being much more sort of open source about the work that you do, so that it's not being pushed by commercial interests secretly, but instead it's open, it's discussed, it's known by everybody involved at all times. So given wildness and artifacts, I think transparency is one clear kind of consideration, transparency in research. I think also inclusiveness is important. So why do I think inclusiveness is important? So like I mentioned, I've been involved in the ethics of climate engineering research for a few years. This is Shishmaref, Alaska, which many of you will know is basically disappearing because of stronger, more powerful storms and rising sea levels. And in our research on the ethics of climate engineering, we had a PhD student who traveled to Arctic Alaska. He also traveled to the Pacific Island, several Pacific Island nations, and also to sub-Saharan Africa. It was a great research project, by the way, and probably pretty fun for him. And he chatted to people. He said, so, you've got a problem in that your village is disappearing. I know some people who have a solution. The solution is stratospheric aerosols and cooling the climate down. What do you think? Would you be into considering cooling the climate down through stratospheric aerosols? So his research was an attempt to include people who had not typically been part of this discussion about the ethics of climate engineering. What he found several interesting things. One of the interesting things is if you're about to lose your village, you're probably more open to this kind of thing than a lot of other people are. So he found quite a lot of cautious acceptance. He describes it as a reluctant acceptance of at least looking at these sorts of technologies. But what he also found, which nobody had really anticipated, is a real concern about geopolitical dynamics that climate engineering might cause. And if you read this quote from one of the subjects that he interviewed in the Arctic, that Wiley Carr is the PhD student who went up and did this research. We published this last year. There's a worry about power, like who gets to control whose lives. And it's a worry that obviously reflects historical truths for this respondent. This was not something that a lot of the climate engineering researchers had thought about. They thought, well, the issue here is sea level, the issue is temperature, storms. Like, if we can cut down on those things, all will be good, right? And people would love what we're suggesting. Well, what Wiley found is that people are reluctantly open to it, but they have a lot of other considerations that they bring to the table before they are willing to say, oh yeah, you guys go ahead and engineer our climate for us. So inclusiveness, I think, is another lesson that these sorts of technologies demand from us. The research must be more inclusive. And then finally, this is a sort of additional consideration that you'll see will relate to the considerations that I've just articulated. But just as Esfelt said, the only way to do this research is to do it publicly and transparently. Some people are saying that the only way to research technologies that are planet shaping is to research them not for the purposes of making money, but for the purposes of creating a public good. And people who've thought about climate engineering have zeroed into this right away. There's something called the Oxford Principles in climate engineering. And what this means when you regulate something as a public good is it means you don't allow people to see this as an opportunity for profit. You only allow people to do it if they see it as an opportunity to make the world better. And people whose lives you're trying to make better also see it that way. So regulating geoengineering only as a public good is one of the considerations. Public participation in decision making is another consideration in the Oxford Principles. And then there's a few others added on the end here. Open publication of results, independent assessment of impacts. And then the fifth one is sort of a absolute condition of technologies this powerful. You would never deploy a technology this powerful unless you had in place some sort of governance mechanism. Okay, I'm almost at the end of what I'm saying. I have about 2 more slides. So just to sort of look back at where we've gone, we've talked about technologies that are planet shaping. We've talked about wildness that I would submit, along with this guy Stephen Vogel, who I've introduced you to here, that I would submit is always going to be present in the things that we build. And we've made some ethical kinds of observations, generalizations, recommendations for how to proceed with these sorts of technologies. The last couple of remarks I want to make really address the sort of bigger environmental picture here. And I think this came up yesterday at the end during our discussion. I think this needs to stay on the table, the sort of sense of where the opposition to these extremely powerful emerging technologies come from. So in the environmental community that objects to these sorts of technologies, and I'm thinking, any of you familiar with the ETC group? It's a Canadian activist group. They basically, they oppose synthetic biology, they oppose climate engineering, they oppose GMOs. They're sort of a hardline environmental activist group that tracks these technologies and tries to make people aware of what is going on. The type of opposition that comes from people like the ETC group is based on a nostalgia for the planet as it was, a concern for the planet that has become, and almost an apoplectic fit about the planet that the synthetic age might create. Like the concern about the Anthropocene and the damaged planet operates at one level. The concern about the synthetic planet, I think, operates at a whole other kind of level. And I think that's what motivates people like the ETC group. And they see this literally as a fork in the road. Either we respect something of the world that we've inherited, or we say we can trade that world away and create something entirely new and probably very risky. So when one thinks about those emerging technologies, I think it would be foolish to forget, I've parodied the ETC group here as being extremists, but I think they are the extreme end of a very widespread attitude about the reassurance of nature that is natural and a concern about nature that is transferred into something synthetic. So I really appreciate your attention, and happy to chat or take questions or whatever you want to do next. Yes?
I have a question. So this is something I've thought about a lot. In my past life, I worked for an institution that funded things like development of the internet and synthetic biology and things like that. So it might shock people, but there are folks who actually agonize over the ethical implications of the technology we develop. And the thing that I think concerns me most is that when we talk about the ethics, we talk as if we are assuming that our very understanding of governance and technology can in any way function the way that it has historically. But the very technologies we're talking about are being democratized faster and faster, so that the idea of a society might make a choice to do something, but the power of any number of rogue individuals is significantly greater than it ever has been, and it's not clear to me how that continues to progress. And it's just, so we can societally decide that we would choose not to do human genetic engineering. But, and I'm a cynic, I guarantee you that there will be any number of people who will ignore that and do it anyway. And so it's not clear that we have the control in governance that goes with these ethical solutions. And I would love to hear how you think about that.
Yeah, no, I think that's a fantastic point. And it's sort of an unanswerable truth, isn't it? It's just true that...
There's a wildness to the governance process, right? It was just sort of in the middle of it, I don't know.
Yeah, no, that's exactly right. Like socially, there is a wildness here. People are going to pursue these technologies. People are going to push them, sometimes because they can make a lot of money out of them, but sometimes just because it's fascinating to do it.
Right. Because they think it's a good thing. I mean, the genetic engineering of things, which you might believe is for the good of your society, is the classic example.
Yeah.
One of the things we did is we actually funded a program specifically to develop technologies that would allow the reversal of gene drive technology. Because the idea of a gene drive is that it's not reversible. And so we said, okay, well, let's focus on safe gene drives. But you understand in our heart of hearts, because of our lack of understanding of the complexity of things, the tools you create to make gene drives safe might in fact create a whole new level of capability that makes things make them more dangerous. Do you know what I'm saying?
Yeah, absolutely, yeah.
You're caught in
That's the physical wildness.
The things that is,
Yeah.
in my dark days, it's really hard to live with. There are days when I'm very optimistic too, because I realize the potential of these things to be great for society. But it's just so tied to human nature and not to science anymore that I'm not sure how we think about it.
Yeah. So, I really appreciate the sort of spirit of the question and the spirit of the comments. There is, I said this yesterday too, but like there's things to love about this stuff, and there's things to be absolutely terrified about. And the difficult territory to occupy is that middle territory where you recognize there's things to love and there's things to be terrified about. The points about our social structures having this wildness that means that we're never going to be able to fully govern them, I think those are completely legitimate points. So how do we respond? Well, I don't think we respond by saying, all right, we've got to sort of crack down with our governance mechanisms and eradicate all of this, these sort of social uncertainties. I think the best we can hope for, which is a sort of imperfect response, but it's why I wrote the book, like the best we can hope for is to say there's really big consequential stuff happening with some of these technologies. Consequences that literally change everything that we are familiar with, that we've taken as a given and taken for granted. And so the more people that are aware of this, the more people will see that having some sort of public discussion and some sort of regulatory structure is better than just letting it be a free-for-all. So my response is an imperfect response, because you can only have an imperfect response to the realities of the situation. But yeah, your comments are so well taken, because I think you've got it completely right there. Yeah, Patricia.
Well, so thanks again. It was a really interesting talk. Some really insightful talks in a row. I think one question I want to ask is maybe more on the science side of things, which is, the synthetic age idea, you're emphasizing the intentionality, which kind of implies that going alongside intentionality or the deliberate nature is that you are able to know and predict what's going on. What separates genetic engineering from just agriculture is that people actually understand the genes. People have been manipulating the reproduction of species for thousands of years, but only now do we understand that. But then Vogel's points suggest that you can really never understand what's going on. You can understand maybe the process before you release whatever it is you created in the wild, which kind of gets to the heart. I mean, a lot of what we think about science is that it is working toward perfect, ultimate understanding. So, I mean, do you think that the synthetic age can work toward a perfect understanding of all these processes, or is that simply impossible?
Yeah, that's a really good question. And I'd love it if Steve Vogel was right here, so you could ask Steve Vogel that, because he's the one that really needs to answer it. So, obviously we are on this curve towards greater understanding. And certainly sort of knowing more and more about how genes work and what they do gives us more and more kind of understanding. One thing I think is notable about, I mentioned Craig Venter. So in 2016 he constructed this minimal genome of this organism, and it was he took what was already a very small naturally occurring organism and knocked out genes one by one to find which ones were essential for life and which ones weren't, and eventually he came up with this organism which I think had 473 genes. I can't remember if that's the number, but so he's like, all right, I'm Craig Venter, I construct genomes, and now I've built you the smallest genome that can function for life. And you know, he put out all these sort of press releases saying things like, you know, this is a historic moment in the history of the planet. For the first time, an organism has been built by a person and a computer instead of by nature. You know, so he was essentially saying this is the synthetic age. But just when he was starting to sort of swagger at his most and feel most supremely confident, he said, oh, by the way, of these 470 genes, 140 of them, we have no idea what they do. Absolutely no idea what they do. And he said, I think the lesson here is that we need to be a lot more humble about what we can know about biology than we thought. And to hear that from Craig Venter, you know, Craig Venter has spouted so much confidence about synthetic biology that at one point, Jay Kiesling, who's a California-based synthetic biology researcher, when he was asked a question about what aspects of synthetic biology need regulating, he said the only thing that needs regulating in synthetic biology is Craig Venter's mouth. Because Venter just can't stop being supremely confident about what he's doing. But in this case, he said, no, a third of what I built, I have no idea what it does. So then, you know, with Vogel in the conversation, you say, all right, Craig, is it just because you don't yet know what it does, and in a few more years you will know what it does? Or is it because you're saying, you know, biology is more complex than we can know? And this is where I think you bring Vogel back into the conversation, because Vogel says, you remember the slides where I had 6 different Vogel quotes? Vogel says, part of what you do when you build something is you put yourself into conversation with processes that are not your processes and are never entirely knowable. Because it's not just one process you put yourself into conversation with. You put yourself into conversation with multiple other processes. And so, you know, with genes, for example, there's all these epigenetic factors, right? It's not just what the gene does. It's what the gene does as it's exposed to all these other kinds of factors that also affect the way that gene is going to operate in that environment. You know, one of Venter's observations about the synthetic organisms is that there's a massive difference between an organism operating in a lab and an organism operating in an environment where all these other factors are in play. So just to, you know, return to your question, is it that we cannot ever know it, or is it that we just haven't kind of got there yet? It seems to be a little bit of both. Like, we can get closer, but maybe we can't get there. You know, we can't get to the destination.
So maybe another piece of that then is there a level where it doesn't matter, right? Because there are certainly aspects, you could argue that you can still design a perfectly acceptable engine, and while there might be quantum effects that are occurring that you don't fully understand, can't model, you don't care.
Yeah.
So there may be levels of some of these complex systems where we will establish a set of rules and boundary conditions for which things are manageable. I'm not saying I believe that we this will apply. I'm just saying that is another sort of thing where it may not matter as much if it's fully knowable.
Yeah.
But can we get to a state where it is predictable at the scale that is relevant?
Yeah, and I think that's sort of what happens, you know, with airplanes, for example. You know, if you look at that photo of that Southwest airplane, you might think, I'm never going to get on a plane again. But then you think, well, no, I'm okay with it because, yes, metal fatigue happens at weird times where we can't imagine. But enough is known about the way airplane engines operate that I can get on that plane and I'm just going to take my chance. You know, I'm going to take my chances and feel pretty.
Less risky than crossing the street.
Yeah. So you feel pretty good about the amount of wildness that has been eliminated. And perhaps that is as good as we get, you know. How much wildness do we need to eliminate before we can proceed? But we must always be aware of the residual wildness. And I think this issue is particularly acute when what you're talking about is not whether to fly the airplane from Denver to Miami, but whether to send a gene drive out into a wild population I mean, like the question becomes so much bigger when you're doing that, or whether to engineer the planet's climate. It seems like the sort of consequences are exponentially larger. And so I think this is why I think this idea of a synthetic age, it's a potentially powerful one, because it's a line which, once you've crossed it, the consequences have all become that much bigger, because the processes have become that much more fundamental. But I like the compromise you're offering, that good enough to go, and that allows us to sort of continue down some of these paths. Okay, thanks very much everybody for your patience and interest.
Thank you everyone for coming today, and please